Hi.
Hi.
So please introduce yourself.
Hi, my name is Sue Ryan. I'm VP of Marketing for a company called Frore Systems, and we make the AirJet.
And is that what you're holding there?
So this is an AirJet, and it's a solid-state active cooling chip.
All right, so let's enter your Computex 2023 presentation. And as soon as I get into the room, I feel it's cooler in here. Is it already running the AC?
Yes. No, I wish. Unfortunately, it is not, but it is very cool in here.
So what am I seeing here?
So here you are seeing these are AirJet Minis. This is our smaller product. These are AirJet Pros, and this is the larger one. This is going to go into mass production later in the year. The AirJet Mini is actually in mass production right now.
And
so this is a demonstration, and it shows how the air is being blown out of the AirJet Mini chip.
all right, and you call it a chip.
Yes.
But it's a cooler.
It is. So the reason we call it a chip is it uses a lot of the chip manufacturing capabilities, and it's also a it's a device in unto itself. So this is actually inserted as it stands as a product into the host product to remove heat, to either double the performance or make it smaller. There's a whole lot of benefits to using it.
Yeah.
And those, basically it can double performance, it can make it lighter, faster, thinner, dust-free. It makes it dust-proof because you can put a dust filter on the actual device as well. So you can have a computer now which has active cooling and no dust. So basically it's kind of like you can forget the fans. This is actually a much more efficient, quieter way of doing
It sounds like
removal.
one of these inventions when people talk about the forever energy machine or something like that, and it's hard to believe. But this is, people are coming here to Computex 2023, and you're actually showing it, and there's no magic, there's no tricks.
It's actually working. One could argue it looks like magic, but when it comes to does it actually work, this is actually the Gold Best Choice Award from Computex. So we submitted for that. We've won a number of awards. So that's kind of validates the fact that it is actually real and works.
And there is a famous YouTuber who comes by your booth and does video and is impressed.
So that is Linus from Linus Tech Tips. So his video is already, I think, approaching 2 million views. PC World magazine has also done a number of stories on us. So we've really had that kind of close look from the media and from customers. And of course at Computex we had the first mini PC in the world was announced that's going to actually have these chips in it.
And here's some illustration of all the applications. So you could be cooling SSDs.
Yes.
So now suddenly, potentially you can have faster, bigger storage, and it's okay.
Yes. So now, especially as the interfaces move from the Thunderbolt 3 to the Thunderbolt 4, and there is the capability to do things faster. At the moment, that's really hard to do because of the thermal envelope. And if you see the new ones coming out, they've got these massive, great heat sinks on them. Those heat sinks can now go away, and you can replace them with an AirJet Mini.
Because my SSD gets really, really hot, and I use it to cook breakfast and stuff. It gets really hot. And how about smartphones?
Yes.
So you can even target this.
Yes.
You can have the most powerful smartphones in the world.
Yep, and when you look at smartphones, if you actually look into the 5G networks, the 5G networks actually don't work very well because the heat generated by the modem shuts them down and they revert back to 4G. So you really need to look at that when you're really what constrains the performance of these devices now is not the capability of the chips inside them, it's the heat. Heat really limits the performance of them.
Nice. And here I see notebook. Mm-hmm. So this is kind of like the big talk of the show, no? You're like, you will help those laptops just run
Absolutely.
at max.
We can,
overclocked.
Yes,
constantly.
We can double the performance in the same super slim design, and we actually have a sample inside, so I can show you that. So, but the same with stick PCs, gaming smartphones, even LED lights. Like all of these products. One of the things when we came out of stealth, and launched the product in January at CES. This wall is actually a collection of all of the inbound calls that we've got from people who are desperate, wanting to solve their thermal issues.
For example, there's a company, I'm using Panasonic because they don't have the same problem like Sony. I'm joking, right? But they have this problem where they set cameras that sometimes overheat.
And they
it's
shut
kind of
down.
sad. Mm-hmm. Like when you buy a camera, it should just work.
Yes, exactly.
This could help.
Yes.
So you could be doing 8K video recording and your camera can stay thin, light, and be fine.
Silent.
Silent?
Which of course when you're using a video recording, it has to be quiet. You don't want a noisy fan there, so that's been a limitation. Now you can do it.
But one of the things he said in his video, he said right now it sounded a little bit noisy.
Yes,
but that's because it's not optimized the whole thing yet.
Yes, so he was looking at our laptop sample inside, and that's where we actually retrofitted a Samsung Galaxy Book Pro with AirJets. So where the air comes out the back through this spout, it actually hits the hinge on the laptop.
It's not designed for this.
If we had designed the laptop around AirJet, we would have ensured that it had a clear path for air. So what you can actually hear is the air coming out and hitting the edge of the casing, because it wasn't a laptop that was designed for AirJet.
I can imagine the people, this guy, for example, I can imagine his life is very noisy.
Yes.
It's like entering a aircraft
noisy
when you go
and
to the
hot.
cloud server area.
Yeah.
Are you going to help with that?
Potentially, yes. So we can do spot cooling on the memory, on the M2 storage, so we can do read writes faster. And that's really one of the things that is really important in the data centers too. It's the speed of transfer, and again, that's dictated by the heat and the thermal envelope.
It sounds like it's the biggest challenge they always have when they build the cloud servers, the server rooms. It's always heat, too much power, and but if you help these guys, it's like huge. And they also pay $50,000 for a board and stuff. They have bigger budgets.
Yes.
So there's been lots of discussions about this here, right?
Yep. So we can really, any one of these we can help. So whether it's storage, it's writing, it's LED lighting, gaming, phoning, Wi-Fi access. Automotive is going to be a little bit further down the path because the certification requirements for avionics and automotive is going to take us a little bit longer. But I have to tell you, when there are 3,000 chips in the average car, that's a lot of heat, and they're really interested in our solution that we've got.
It sounds like it's one of the challenges with electric cars, also with all the batteries. They have some huge challenges that they kind of try to figure out.
Yep, and self-driving cars, when you think about the LiDAR that's required to help navigate them, they have the same kind of heat problem. So it's a ubiquitous problem with the IoT devices that are getting more and more common, need more and more power in smaller and smaller form factors. It really is, it's a huge opportunity, and we can add a lot of that value across a lot of different industries.
My next HDMI stick is just going to be full PC power, and it's just going to be cooled with this. And then you talk about TVs, because maybe there's a light field, 8K display, 16K, all this. This uses a lot of power, and you're going to maybe help them.
Heat.
And that's not only on the electronics. I mean, the whole thing is electronics, but also display parts, right?
Yeah, there are many applications for this, and we are actively working with customers as fast as we can, because there's been a lot of demand, as you can imagine, because everybody wants more power and more capability in smaller and smaller packages. And if you want that, a side product is heat.
And you're going to help when I go to the dentist, is going to hurt less, or what? What's going to help there with the dentist?
Basically, it's not going to get hot. So again, as you're using that, it gets very hot on the handle because it's using power. So again, if you can put a cooling device in it, it removes all of that heat.
All right. So here you've had such a busy Computex, and people come in here, and for example, you show you showed comparison, right?
Yes, so basically one of the cool things about the AirJet is it has a really high back pressure or suction force. And this really shows that to get the same suction force out of a fan, the fan would be this kind of size. And trust me, you don't want to be carrying one of these around in your laptop or your handheld gaming device.
So actually on social media, you don't care if people say Frore sucks.
No, exactly. Yeah. It sucks. Yeah. A lot of air that is.
Yeah. All right. That's pretty good. And so what goes on with the oh, here's also helping with the
camera.
That's on your website?
Yep.
All this?
Yes. It's all on our website.
And so it's like listing all the different applications.
Yep.
To do more and more terabyte SSDs and everything.
Exactly.
And what goes next in the demo?
Yeah. So this is really cool, actually. This is called a Schlerian image, and it actually visualizes the heat. So this is actually happening live here. It's a little bit on the geeky side, but it's a visualization of the airflow coming out of these two AirJets. So if we were to go down there, let me run over and stick my hand in it for you. If you keep looking over there, you can see in real time, I can put my hand there. And if you were to come and feel here, it actually, you can feel the warm air coming out of here. So this is actually one that's happening in real time, so people can see what the actual airflow is of it. Can you feel that heat coming out?
Yeah.
Yeah.
All right. So it's good.
It's cool, right?
All right. Yeah. So how long has it been in development?
So Frore spent 4 years in stealth doing this. They actually came out of stealth mode in December last year, and then at CES in January we actually launched the product. So we've really been in market maybe 4 months, and the response from industry across so many different segments has been phenomenal.
And where are you based?
So our head office and R&D center is actually in San Jose in California, and our fab, our manufacturing plant, is actually here in Taiwan.
And what do I see here with it's showing how the mini PC can be designed?
Yep. So this is actually the product that was launched here this week. So this is the first mini PC in the world that has AirJet Mini in it. So you can see it's got two chips in there, and they're actually placed onto a copper spreader like this, then put into the device. The air is then comes in through these side vents, which have dust-proof covering over them. The air circulates around the device, is then sucked into the AirJet Mini. It transfers the heat. So air that is completely saturated with heat exits out of those two super skinny exit vents that you probably have trouble seeing because they're so small.
That's a very compact area of air coming out.
Yes.
And this is demonstrating?
Yeah, so this is one of the demos. On this side we have the mini PC, which has actually got the AirJets turned off. On that side we have the AirJets turned on. So you can see here the performance is, the CPU power is 1.2 and the system power is 9, which is really low. Nobody would use it like that. And you can see the impact it has on this heavy workload that we've got here. If you can see over at this one here, you can see when we turn the AirJets on, it jumps from 1.2 up to 6.2. It normally runs about 7, and the system power is up to 20. And if you can see the video there, it's actually running smoothly, not jerky like this one.
All right. So there it's active, and
yes,
the hot air is coming out.
Yep. And they're still kind of fine tuning. This is going to be available in probably about three months' time, and they're tweaking the rest of the system because the efficiency in the rest of the system isn't as good as it could be. So we anticipate by the time this is actually out in market, this should be closer to 9.5, 10 watts.
But I mean, when I look at this, it looks like 10 times faster, but you're talking double.
Yes.
Because from 1 to 10, it's 10, but I mean, it could be kind of like double.
Yes. Yeah. So basically, when this hits the market, it'll be twice as it'll have twice the processing power of the previous generation that didn't have AirJets in it.
And it's just an Intel i3 and 300, and you just crank it up.
Yep.
So I guess these chip makers must be very excited by your presentations here, right?
I think so. Yes.
And the question is, how soon, how much, you know, all this is a big question, no?
So how soon is these are actually being mass produced now? So the AirJet Mini is actually available now. As you can see, it's been integrated into the world's first mini PC here, a Zotac product. It's actually the Zotac. You can see here how it fits together. It's the Zotac. It's the Z-Box PI430AJ, standing for AirJet, with AirJet, and that will be on the market probably late August at this point.
But there will be a certain cost difference between that version and that version,
yes.
Which hopefully it's not double the price of the whole box.
No, I mean it's really up to our customers how much they price it. It definitely does cost more than a fan. But it is obviously an acceptable price increase because our customer is going with it. But the benefit is it costs a little more, but it doubles the performance. So really, AirJet is ideal for people who either value much higher performance, or they need the product to be silent, or much smaller, or dust-free. And if you have multiple of those, then most people are really, really excited.
So
this.
somebody's saying in the chat, just don't call it the hottest new thing.
No!
So it's the coolest new thing, right?
I like that. It's definitely the coolest new thing.
Yeah, and here we see, this is, are you doing a security, like?
Yeah, so this is actually a ring camera. So we bought this off the shelf. We've integrated one AirJet Mini into it.
So now your Ring camera can be 8K, 120 frames per second.
Yes.
Right? Before it's just a little 4K thing.
As soon as they improve the performance of the chip so they can do more, they now, you can see with the commercial, it's running at 45.9 degrees. With the AirJet, it's 31.8 degrees. That difference in temperature actually equates to extra headroom that you can put more processing power in to get the AirJet version up, and you'd see a dramatic increase in performance.
Nice. Can you describe a little bit?
How about the lighting one is pretty cool, actually.
Yeah. So this is how much you can reduce a lighting product.
Yeah, so this is an application that we had no idea about until they came to us. But here you have, if you look into the high quality LEDs, so LED downlights that are in hotels or shopping centres, are really expensive, high quality ones. If you were to see up above the little downlight, this massive box is actually in the ceiling. And the reason it has to be so large is it has to be totally sealed, so it has to be totally airtight, and it has to be large enough to dissipate the heat coming off this LED module. So to do that, they need this, which is the biggest heatsink I think I've ever seen. It's massive and it's really heavy. So they have to do that to put it in here to keep it cool. What we did was they reached out to us and we were like, I think we can help you. And we actually took this and we took a module that looks like this, and we popped it on the other side of the LED module, and we basically replaced this really, really heavy, my arm's getting sore just holding it, with this little 2 AirJet Mini thermal module. And what that enabled us to do was go from a product size that was this to this.
So you're changing the lighting industry.
Completely, and it's a 90% decrease in volume. It's a 72% decrease in weight, and the temperature is a little bit warmer, but well below the threshold. So the value that this customer is getting out of this is not only the performance and the increased demand for a smaller, easier to use product, it's also the savings on cost and storage and shipping costs because of this big weight. I mean, it's really brings all of this value.
One of the biggest costs in all consumer electronics is power consumption. So you could potentially also use half the power at the same performance. Because you do double the performance at the same power. Or how's the power comparison?
Power consumption isn't necessarily one of the selling points that we have, but you're absolutely right in that you can do twice as much.
So that's going to be exciting too, to see what happens. Here's a laptop.
Yep. So this is these are two Galaxy Book Pro 2 Pro 13s. This one is straight off the shelf, and you can see it's running with a system power of 20 watts and a CPU power of 12 watts. This one over here, we've actually retrofitted with 3 AirJet Minis that you can see under here. 1, 2, 3. So the way this is performing at the moment, you can see up here, is at 25 watts and 16 watts. So you can already see just with the 3 AirJet Minis in here, we've already had a significant increase in performance. If we'd designed this laptop, we actually would have put a 4th one in place, and that would have taken this from 16 up to 20 watts in the same super slim design. The other thing that's really cool about this, again, is because of that high back pressure. In a laptop like this, I don't know whether you can see it, but it's got, if I lift this up, it's got an air vent across the back here. If you can see all those air vents, that's there because the fan was here, which you can see corresponded to those air vents. The reason those air vents have to be there is because the back pressure or the suction power of a fan is really low. So when we put the AirJets in, we can remove any air vents on the device, except for one air vent, one intake vent along the back, which we cover with dust-proof material, and that makes the entire laptop dust-proof, which is amazing. If you've ever looked inside a laptop with a fan and seen all the dust bunnies in there, very unattractive.
Somebody's asking, somebody's asking, are they using cavitation to increase throughput of air? But I guess it's a whole question of like where the air comes from and stuff, and you just grab the air. You don't need to have huge holes everywhere to grab the air. Oh no.
So the air comes in just through a super slim slot on the side. So we just have one slim inlet in the back. We cover it with dust-proof material, which doesn't impact it at all because of the back pressure or the suction force. And then that air actually is designed to come in, circulate around the actual laptop to cool it before it's sucked into the air jets, and then it then takes the it then transfers the heat directly from, in this case, a vapor chamber into the air jets, where the heat is then transferred into the air and ejected out of the device.
So here, it's not an optimal design, right?
No.
But you're already doing 33% more performance,
yes.
But you also use more power on this one.
Yes.
But what you're claiming is 50% potential.
Yes. Yep.
So that's going to be exciting.
Yeah.
And that's useful both for Intel and ARM CPUs, like for any CPU, they all do heat.
Anything that generates heat, this will remove heat from. But the real sweet spot for us are compact devices that need increased performance or decreased size and dustproof and silent. So if we get all of those things, then this is really the perfect fit for it. And that's why we've had so many inquiries from places where we never even thought about it. Another really good one is actually the SSD. So if you've seen the newest high-performance SSDs coming out with the Thunderbolt 4 on it, you'll notice a lot of them have a massive big heat sink on it. So here we've taken a SSD accessory, we've retrofitted it with two AirJet Minis. And you can see here, if you could feel this, this one is the standard off-the-shelf one, really hot.
Oh, this is full.
This one is the AirJet one, and it's significantly cooler.
Oh my God, you can cook an egg.
Yeah, it's hot.
Yeah.
And you can. So for the people out there who can't touch it, the temperature up here of the commercial one is 69 degrees, and on the AirJet one is 56 degrees. Now, in an ideal world, we would actually show the increase in performance. But unfortunately on this device, this is a Thunderbolt 3, these are performing at the highest they can with a Thunderbolt 3. If we had a Thunderbolt 4 on it, we would be ramping up the performance here, and the temperature would be the same, and you would see the difference. Well, this is what the projection is, that we will actually, when we have the Thunderbolt 4, we'll be able to get up to that maximum 4 GBs per second read and write.
Yeah, that's what I've been
It's massive
for.
change.
Because Apple and other have been releasing laptops supposedly can do 40 gigabit per second, but the SSD makers are not yet releasing them because they can't.
Yep, and when they do, unless they use AirJet, they're going to have one of those massive heat sinks on it, which are really not very customer friendly, I have to say.
All right. So the mass production is going to happen in some very interesting fabs, and you're designing those fabs?
Yep, so we have our fabrication manufacturing plant is actually here, because this is completely new. It's new materials, new design, new machines to make it, new machines to test it. Everything about it is new. So we've had to build our own fab here. So that's here in Taiwan, and they're going into mass production now, actually, because we've been out of stealth now in 4 months. We've got our customers lined up, so these are starting to roll off and go into devices which customers will be able to buy here in the coming months.
And here at Computex, you did let some people try to open it up a little bit and look what's inside, right?
Yes.
You don't have one that's already open right here?
No? We actually,
It'd be nice to see with a microscope what's happening in there.
Yeah, so number one, we didn't let them look at it with a microscope either. But basically, if you look inside it, there is a cavity in there, and there are vibrating piezoelectric membranes, and they actually cause the suction force. And then air comes down and impinges in pulsating jets that move at 200 kilometers an hour in here, which blows me away, literally. That they impinge on the copper base here. And that vertical impingement at 200 kilometers an hour breaks the thermal barrier, and that enables the air inside this AirJet chip to become completely saturated with heat and then ejected from the device out of this little spout.
All right, that's really cool. So I guess there's potential for so many other markets.
Yep.
And here it's hot in Taiwan.
Yes.
Are you going to be air conditioned?
Air conditioners are a bit big for us yet, but really this could be scaled up or down. But we're only a very young company. We obviously have a very, very new and innovative tech that can be expanded to all kinds of markets. It's just what makes sense on our roadmap.
Hello, I'm Mr. Beast. No, I'm not Mr. Beast actually. But if I was Mr. Beast and if I was sending you a bunch of money, I would use Wise. Wise is a really smart way to send money around the world. Tiny little fees. Check out my video, a 7-minute video where I try to explain some more. It works in hundreds of countries. Every time you go to a different country, use your Wise card or use your Android Pay, your Apple Pay to do all your payments with a tiny little conversion fee. If you have some customers in different countries, they can send you money to local bank accounts in the US, in Europe, all over the world. You can get local bank account details. They transfer tiny little fees. Don't use PayPal anymore. Don't use Western Union. And don't use your bank to send money, because it's surprising, but you wouldn't know maybe, but they take fees that are gigantic, that are pretty big. Just use the Wise. It's smart.